Hello, my name is Mark Bowen, and this is mine's and Kimberly's final project. Now, what our final project is a heater system for my poorly insulated room. So, the way this heater system works is that we utilize the Raspberry Pi as our server. All the data is collected and processed on the Raspberry Pi, and once the data has been processed, it then sends information to our CASA smart plug. Now, the smart plug and the Raspberry Pi establish a UDP connection on port 9999. We utilized a Python library to simplify the socket connection process, but in general terms, it uses UDP tactics, which means that after the connection has been made and completed, it forgets it ever happened. So a couple of the data collecting tools that we have are a temperature and humidity sensor, a rotary encoder, and a weather API in our code. So I'm gonna begin starting the program, and we're gonna see how it runs, processes data, and sends data to the node involved. Okay, so we're gonna start it. So currently I have my desired temperature set at 23 degrees Celsius, which is this one right here, and I can toggle it using my rotary encoder. So the data being collected from the rotary encoder is processed approximately every 0.2 seconds. However, the data processed and collected from the temperature sensor and the weather API is processed and collected every minute. There's two reasons for that. First of all, the weather does not change drastically in 1 minute. And two, we have a limited API calls, so we're limited to 60 an hour. So I'm going to raise the temperature using my rotary encoder. Red means that we are not at our desired temperature, and green means that we are. So in a couple of seconds, our Raspberry Pi will begin collecting data from the temperature sensor and the MPI. It'll process that data to determine whether or not our heater should be on or off. So, which it just did. So, inside temperature is 23, outside temperature is 14.7 degrees Celsius, and since we are not at our desired temperature, Henry the heater has woken up. So again, the Raspberry Pi processed all the data, and then it determined that the heater should be on. So therefore, it now sends commands to the CASA smart plug to turn on. And additionally, the CASA smart plug sends back information, which is right here on the screen, telling us at what time Henry the heater woke up. So this information here is from our CASA smart plug. So our heater is on right there. It's warming up, trying to get us to our desired temperature. Now I'll explain the reason for collecting the weather data from the API. Now, the reason we collected that data is because we determined that if it's warmer than 21 degrees Celsius or 7 degrees Fahrenheit outside, then there's no reason. So see here, boom, temperature, quick update. The temperature has changed to 24, which is our desired temperature. So our Raspberry Pi processed these two bits of information here, determined that the Henry should go to sleep. It told Henry to go to sleep because now it's off. As you can see, our CASA smart plug is off. Right there, there's no blue light. And the CASA smart plug then sent back information telling the Raspberry Pi at what time it turned off. Okay, so that just happened. Okay, and before that, I was explaining the reason for our weather API. So we determined that if it's warmer than 71 degrees Celsius or 7 degrees Fahrenheit outside, then there's no need for Henry the heater to be on. This is because the primary purpose for Henry the heater is to keep the room warm at night and early mornings, because that's when it's the coldest, and that's when you could get sick from it being too cold. So it achieves this purpose by maintaining a steady temperature. So as you can see here, the temperature has gone down, and it told Henry the heater to wake up. So our our Raspberry Pi processed information, which it does every minute, processed the temperature inside, temperature outside, determined that Henry the heater should wake up, told Henry the heater to wake up, which is now on, through the case of smart plug. And then the case of smart plug sent back the information of at what time it turned on. So one last thing is the toggle limits for our rotary encoder. So here I have a limit of 23 degrees Celsius, and I can lower it all the way until 17 degrees Celsius. Now, essentially this means that I want my heating system to be off, because it would be very difficult for my room to be this cold. And if it is, in fact, this cold, then I would want a heater so I don't freeze. Yes, that's the processing from the rotary encoder, temperature sensor, and all this processing, all this data collecting, it all happens on the Raspberry Pi. And so the node-to-node connection is simply just Raspberry Pi sending a command, case of plug, Raspberry Pi sending a command, case of smart plug receiving the command and sending back information. And then they forget the connection ever happened. So we're gonna wait a little bit because I set it to 7 degrees Celsius, and we're gonna wait for Henry the heater to turn off in a moment. And once Henry the heater turns off, I'll reset the temperature to the desired temperature, and it'll essentially keep my room warm. So, you know, whenever I get below the desired temperature, which normally hovers around 23, 24, or 25 degrees Celsius, depending on, you know, how warm I want the room, it'll turn off. 25 degrees Celsius is a little warm, so I wouldn't recommend putting it that warm. But as you can see here, it took the temperature, it took the outside weather, and yeah, and so Henry the heater was already off, so it didn't turn it off again because that would be redundant. So as you can see here, it stayed off. That's one of the things we designed in our code for the heater to stay off. So the same thing will happen when I set the temperature higher than the desired temperature. So here I set it at 26. I'll set it back down to, you know, 25, which is still a little warm, or 24. So essentially in our code, we have it so that if the heater is already on and it's supposed to be on, it won't. Okay, so here, boom, like I said, I changed it to 24, so our heater woke up. So in our code, we have it designed that so if our heater is already on, then there's no need to turn it on again. There's no need to, you know, waste that connection. So essentially what happens is the only connection that happens when our heater is already on and it's supposed to be on is that the Raspberry Pi still connects to the case of smart plug, but this time the only message it's sending is that it's asking the case of smart plug is if it's on. And if it's on, it's supposed to be on, then it returns is on, which is true, and nothing else happens. So we'll just wait for that to work. So here currently it's on and it's supposed to be on. Hopefully it doesn't get too warm. That's why I'll raise it that way just in case it gets too warm in my room. So now I have it at 26. The current desired temperature is 26. Current is 23. In a couple of minutes, we're gonna see that it's gonna remain on, which it just did. Boom. Here, it took the temperature, then took the outside temperature, and it did nothing else because it's already on and it's already supposed to be on. What it did internally was it asked the case of smart plug if it's on. Case of smart plug said yes. So it just didn't tell it to do anything else. That's basically the purpose of our project. Now my room will stay warm despite it being cold at night. And if it gets hot during the day, the heater will automatically turn off. I wouldn't be able to do this without the many lessons I learned in the class, so I really appreciate that. I had a great semester, and I hope you graders have a great winter break. Thank you very much.